proofs. Okay, so again, don't get frustrated with the proofs. Make sure you give an effort of trying them out. Start with the odd ones, obviously, like I said yesterday, because that's going to help you to get to the even ones. And as Cora and I were talking earlier, remember, the things that we introduce in class are probably going to end up in one of the proofs or a lot of the proofs that we do that day. Again, then you can't forget anything that we've already done. All right, so today we're going to talk about segment relationship. What are segments again? Okay. So it's kind of a line, but it stops, right, on both ends. Because they have endpoints. That's what makes a segment. So we start out by introducing postulate. So what's a postulate again? What does a postulate mean in general? It's a rule, right? It's a rule that's kind of accepted. This is segment addition postulate. Again, if you don't understand the abbreviations, let me know, because I'm going to abbreviate a lot. This is one that we'll use quite a bit, especially early, but in a sense we'll use whatever addition postulate a lot. So it could be angle addition, but today we're going to talk about segment addition. So what does this mean to you? Well, this says, and again, you don't have to write all this down if you don't want. If you want to just draw the picture, you can just draw the picture. All of this is in the book, so you can go back later if you want. I don't really care. We'll write up some of the stuff up here, but you decide what you really want to write down. So, if A, B, C are collinear, what's that mean? They're on the same line, right? Then point B is between A and C. Here's something we're going to introduce you to today. Ever seen this? IFF. This means if and only if. So you'll see me write that down quite a bit. Point B is between A and C if and only if AB plus BC equals AC. Right? So again, the words usually confuse me, but some people are word people, so we write it down. But this is saying this. B is in between A and C if I can take this plus that and get the whole thing, right? So the little pieces add up to the big piece. That's segment addition. Again, now notice here, when we wrote this as a math problem, my segments don't have the little bars over top, and it has an equal sign, because we're actually talking about adding sections. And again, so this would usually mean that we have numbers, right? So if I told you that AB was 6 and this was 8, then I know AC is what? 14, because they're added together. But again, just notice that when I'm doing addition, I don't have the bars over top and I use equals instead of congruents. So that's, again, really important. So at the beginning of a lot of these proofs today, if you have something where it said that AB was congruent to something, CF or something, it doesn't really matter. The first step is I'm going to convert them into equals because I know that I'm going to use segment addition. So then, again, this would be definition of congruent segments. Oh, hey. Good luck. All right, so just remember this will be a lot of your first or second, well, it'll be your second step today, right? Because again, we're going to start with a given. So we'll go through proofs here in a little while, but let's get the rest of the notes now. So then the rest of this is about showing segment congruence. And we'll do these a lot. We've already done them once, but we'll do these a lot. And the first one says that we're going to have a theorem. And in theorem 2.1, it says congruence of segments can be, and these are the things that we do a lot of, reflexive. What are the other ones that we talked about? Symmetric. And my last one was the T one, right? Transitive. So again, we'll use these three reasons for congruence a lot, not only in segments, but in angles and triangles as we continue on. So again, what does reflexive mean? Reflexive means that I have the exact same thing on my shape, for instance. So for examples of this, reflexive would be something like BC is equal to BC. So basically they're saying that BC is in two different places, but obviously it's the same thing because it's called BC. So for instance, I told Cora that she plays on two teams, but she's still Cora. So we could say that Cora is equal to Cora on both of those teams. Right? But it's the exact same thing. The symmetric property, that's what we've kind of worked with lately. On the first day, where it was kind of backwards of what the proof said. So if the proof statement said that I had to write it as x equals 7, I'm just flip-flopping them, and that's the symmetric property. And then the transitive property, that's the one where it's kind of the sentence, right? If AB is equal to BC, BC is equal to DF, then we know what? AB is equal to DF. And again, notice in the middle there, okay? I can pluck those two out, and whatever's left over, that tells me the transitive property. Actually, and when we come back to this, because it's congruence, these should all have bars on them. So when you do this, you should be using it with congruence instead. Any questions with any of this stuff? So that's the words, right? Now let's look at some examples of this. So that's it. False. False. Square root of 7? Square root of 7? I don't know if I'm attached one to show now. I think there's 3 little ones.
Okay.
It's probably 40 something.
Okay.
That's
Okay.
Let's look at these real quick, and then we'll get to the other examples. So, what one of these reflexive, symmetric, or transitive properties does this signify right here? If KL is congruent to MN, then MN is congruent to KL. Which one would you say there? What did I do with that problem? Symmetric, right? I just basically flip-flop them. Okay? Next one, if AB equals 10, and 10 equals CD, then how do I know that AB is equal to CD? Transitive. So notice we can do the transitive property without being congruence. So you could have the congruent segments, or you can do it with equals. If SY minus 5 equals RT minus 5, then SY equals RT. What would you say for that one? Is that any of those up there? I would say this one's probably just addition property, going back to yesterday. Okay? All right. So let's look at some proofs. Again, don't get frustrated. Remember what's a good proof. Okay? And remember to say the obvious. We'll introduce reflexive property in this one right here to show you reflexive property. So the first thing here, it says prove that if AB is congruent to CD, then AC is congruent to BD. So again, the if part, my hypothesis turns into my given. The conclusion turns into my proof. So if I am given AB is congruent to CD, my first step obviously is to write that down again and say given, right? What's my next step? What did we learn today? Today we learned about this segment addition postulate. But again, because we're going to add, we need to do what with our segments? Take out the congruence, right? And the little bars over top. So how do we do that? Do you remember? We turn them into equals, and what is the reason why? Definition of congruent segments. Perfect. All right, so now, where the heck do we go? So the next thing that you got to start doing is showing yourself, what is my proof, right? What am I trying to actually prove? So I'm going to come back here, and here's my proof. It says AC. I want that part equal to that part. Pretty good one today, huh? So, how the heck do I do it? First off, do I have any of those pieces? So again, start with the given. Is the given right here, even though we changed it to this, so basically this is both the given because we're still using the same letters. But is the given shown in those two pieces of the red? A, B, and CD are where? Here's my AB, right? Here's my B or CD. That's the given part. Would you agree? Okay. So, what part haven't we talked about? BC. And what is BC compared to the proof statement? Would you consider BC a part of the proof statement? Is this right here? Now I lost my little thing over here. Is this right here a part of the proof statement? Yes. Which is the red part? Yeah. How? Because BC is in AC. Okay. Is BC into something else? What else? BD, right? So you see where, in a sense, Cora is playing for both teams. Cora is BC and she's playing for AC. And she's playing for DB. Okay, so my next step, anytime that you have a piece that's in two parts, you have to say that to everybody. So what part is in both parts? What segment is in both parts? BC. So BC is equal to what? Cora is equal to what? Herself. Herself. So if BC is in both parts, the next step that I have to say is BC is equal to itself. Cora is playing for both teams. And that's a reflexive property. So now, we introduced postulate 2.9, which was segment addition. What's your segment addition? What's the segment addition for the first part? Meaning, what would I write for segment addition for that right there? AB plus BC, right? Everybody agree with that? And that's equal to what? AB plus BC equals AC. And isn't AC what we wanted? And don't we know what's true about AB? AB is congruent to CD, and BC is in both, right? So that should lead us to also say, the other way, CD plus BC is equal to AC. So basically what they're saying here is the other side of this. And if they're both, this part right here is equal to this part right here, then the answers have to also be equal to each other, right? So we're going to say CD plus BC equals BD. And then we get our last one. So basically what they did, and it doesn't matter how you do it here, they went with CD plus BC 2 times. You could also go with the other one 2 times. You could have said AB plus BC is equal to the segment of CD in the second part. But they went the other way. You understand what I'm saying in that sense right there? So some of you will do it one way. See where they use CD in both cases here? Some of you might have used AB plus BC in both cases. Essentially, you're saying the same thing, you're just proving it in a different order. Okay? And then, basically, I'm taking out these 2 things that are in common. That's how they got transitive property. I'm plucking those 2 out, so what's left over, AC equals BD, should be what we had for our proof, right? So is the proof AC congruent to BD the same thing that we have right now? No. What's the difference again? It doesn't have the congruent sign. So at the beginning you have to switch it into equals, and at the end you have to switch it back. Okay, so again, whatever the proof statement says, even though the letters were right, you have to switch it back to congruence. Make sense? The worst thing about this one right here is that we can't see it all on one page, to me, because we got to go back and forth a lot. So if you wrote this down in your paper, it's probably a lot easier to see. But that essentially, we're going to do that a lot. So here's the other one, or here's another one. But this is where I really encourage you to draw this on your piece of paper and mark it up to show yourself what is congruent and what's not and such. Okay, so prove the following. Here's my given, here's my proof. So again, the first thing that I would do is I would come over here and I would go through and show all this. AC is equal to AB. AB is congruent to BX. So that means I can still use one letter or one slash, right? And CY is equal to XD. Well, these are definitely shorter than these. So now I'm going to use 2 slashes. Okay? That makes sense to everybody? And then they want you to prove that this, oh, that's a bad one, is congruent to that. Or equals to, sorry, equals to. Okay? So, what do you think? What would your first step be? The given. We're getting good at that at least, right? Next step. What would you say? Perfect. So, they went through here and they gave you your given. See how they split the given up? To me, it's kind of confusing sometimes. So my addition property they went with showing just the little parts, which were AC plus CY. So Dave went and did the whole thing like we did in the last one. He jumped down to this step way down here. So what they're saying is they originally wanted you to just show that the pieces were equal to each other because of this transitive property right here. So AC would have been the whole thing, right? And again, we got to go back here. So here's my AC plus CY. And that's what they showed eventually. And BX plus XD is the other side over here. But because of my transitive property at the beginning, where AB was plucked out of the middle, AC is equal to BX, then I can come down to here and say the whole thing again, like Dave said. So again, the best thing for me to do is draw this picture on this end. So that it's probably easiest if you would have just quickly drawn your triangle here, right? You don't remember what it was, something like that, right? Is that kind of right? Yeah, okay. So then this little piece to this little piece, because I should have put a dot here, and then this little piece to this little piece. So then at the end, Dave was right. This would have been what? As a step. My postulate, right? So again, notice the steps here. They said the given, they split their given into two, no big deal. Then they went through and noticed that the ABs were in both cases, so they plucked those out and they said AC is equal to BX. I believe AC was here and BX was here. Agreed? So they said that they were equal to each other. Then they went and showed that this piece right here plus the little piece was equal to this piece plus the little piece. Then they went through and said the whole thing, which would have been segment addition postulate. And then last but not least, AY is equal to BD, and again, then I know that I'm at the end. So, I know you're going to say this is really confusing by the way that we're kind of going through it, but you need to just make sure that you go through step by step, and especially the ones that they give you fill in the blanks, go through them step by step and try to understand how they did each of those steps. Or an odd problem, go through the odd one, and actually at the beginning, go directly to the back of the book and read step by step. So you kind of start to understand the process. Because otherwise, if you don't understand the process, then the whole thing's kind of really, really confusing. And the way that I'm probably trying to explain it to you probably doesn't make any sense right now. But the more practice you can get, the better you'll be. The other ones aren't just about symmetric property and such. I think there is maybe one more we need to look at. Will you turn your book to page 147, please? On page 147, they have another one that you have to fill in the blank. Or you can fill in the blank. Now, some people like the fill in the blank ones because they show exactly what you're kind of doing. Other people don't like it because they had a different kind of version of it in mind. And then it kind of screws with what they were trying to do. So on page 147, if you look at number 1, notice my given up on top. And then over on the right-hand side, you see the figure. Okay? So again, look at it. LK is congruent to NM. KJ is congruent to MJ. A lot like the other one that we have already looked at, right? They want you to prove that LJ, the whole thing, is congruent to the whole thing. So again, this is a lot like the one that we did already. So what would you think? Obviously, letter A, The reason why is given. That's easy now, right? So what's my next step? If I'm going to use addition, I need to take my congruent statements and do what to them? Put them into equals. So my first step is to take A and turn them into equals by, again, see the reason why? Definition of congruent segments.
Take the bars off, right?
Take the bars off. Exactly right. From there then, they're just showing you. So here's, look at the top and look at step C. Step C, they take LK, everybody see that? The little part, like on the bottom, plus KJ, the bigger part on the bottom, and set it equal to the two segments on the other side. But why can they do that? They can do that because all of the segments are congruent from the given. And so, notice my reason why here, why can I do letter C? Don't go all the way to the postulate yet. Because the postulate, what you got to remember in the postulate is that the two little pieces equal the whole thing. So what did they do in C? They just did this part right here, right? They didn't set it equal to each other or to something. They took the two pieces and added them together. So in letter C, the reason why that I can do that is simply the addition property. And then in letter D, they would take it one step further and say, now they're going to take the pieces and set it equal to the entire thing, and that's when you get segment addition postulate. So do you see the difference there? Okay? And then letter E, basically, you already said a portion of D in C. So you're taking those out because you know they're equal to each other. If they're equal to each other, the answers have to be equal to each other. So in E, they say the answers of LJ and NJ are equal to each other by substitution. If you honestly wanted to say transitive property, we could get by with that too, in letter E. And then the last thing they did from E to F is what? They just put the bars back on. So if they put the bars back on, then my reason why again is the definition of congruent segments. So again, this one right here, this is one where you need to just go through and try to fill in those blanks as much as you possibly can. And again, this one was a lot like the one we've already looked at. And so a lot of repetition at the beginning, it seems like we're doing the same thing. We actually are. We're doing the same process over and over again, so you kind of try to get the feel of it. Okay? So, questions? I know it's kind of frustrating and kind of confusing, but the more that you actually try to do this by yourself, the easier it honestly is. Okay? And I realize that a lot of you are going to use the excuse that this is first period, and it's probably not the easiest class to start out the day with, but that's something we just got to work with. So, here's your problems. Number 4 is the fill in the blank one. So hopefully that's a little bit. Number 9 is approve. And number 10 is approve. Number 9 is pretty short and simple. Number 10, I think you can get by with you can get by with 6 steps instead of 8. Sorry, 6 or 7, depending if you combine these. So this would be 6 or 7 points instead. So again, if you need help, make sure you come in and get help. Use each other as a source. Somebody's going to honestly get this before you do. Maybe. But it also helps just to talk